Welcome to this explainer. If you've ever looked up at the night sky and wondered about all that incredible and, let's be honest, sometimes terrifying space debris just zipping through our solar system, well, you're exactly in the right place. Today, we're going to take a journey to understand three major celestial wanderers: meteoroids, asteroids, and comets. Let's get right into it. Okay, let's dive into this. Here's our roadmap from deep space all the way down to ground zero. 1. The cosmic wanderers. 2. Asteroids, the rocky giants. 3. Comets, the icy speedsters. 4. Meteoroids, the shapeshifters. 5. When space rocks strike, and wrapping up with 6. Defending planet Earth.
Section 1. The Cosmic Wanderers.
So, to really understand our solar system's debris, we first got to look at the absolute fundamental building blocks floating out there: meteoroids. They're basically just small fragments of stone and metal, specifically metals like iron and nickel. Out in the deep vacuum of outer space, their surface temperature sits right around 0 degrees Celsius. But what's really fascinating is where they actually come from. They aren't just random, isolated rocks. They're actually broken-off fragments born from much larger bodies, specifically asteroids and comets. It's like they're the shrapnel of the solar system, just floating freely and orbiting the sun.
Section 2. Asteroids, the rocky giants.
And this brilliantly illustrates what we're talking about. Notice that distinct ring of debris circling the sun? That's the asteroid belt, nestled perfectly right between the orbits of Mars and Jupiter. Asteroids are essentially large metal and rocky bodies. Scientists often call them small planets because, well, they orbit the sun just like Earth does. But here's the crazy part. While meteoroids are tiny, asteroids range from 1 meter all the way up to a staggering 1,000 kilometers in diameter. We even have names for the largest ones hanging out in that belt, like Ceres, Pallas, Juno, and Vesta. They are massive, they're freezing cold at roughly -73 degrees Celsius, and they just cruise through space at an average speed of 25 kilometers per second.
Section 3. Comets, the icy speedsters.
Now, while the rocky giants we just talked about are made of stone and metal, comets are completely different. They're essentially dirty snowballs, literally a mixture of gas, water that's frozen into ice, dust, and rocky particles. And size-wise, comets are uniquely massive in a very specific way. They have a distinct head, which can reach up to 250,000 kilometers across, and this magnificent tail that can stretch an absolutely incomprehensible 150 million kilometers long. And oh man, the speed. While our asteroids are cruising at a leisurely 25 kilometers per second, comets are true speedsters, traveling anywhere from 10 to 70 kilometers per second along their own elliptical orbits. Okay, now take a look at the incredible mechanics of how a comet actually moves. Originating from super far-flung regions like the Kuiper Belt and the Oort cloud, a comet travels in a highly elliptical orbit. As it gets closer to the heat of the sun, its speed increases and it begins to melt. That ice turns directly into gas. But notice those glowing blue tails? The solar wind, which are basically powerful streams of particles blowing away from the sun, pushes against the comet. And because the gas has a lower mass than the solid head, that solar wind forces the tail to always, absolutely always, point away from the sun, no matter which direction the comet is actually traveling. It's a beautiful display of celestial physics right in action.
Section 4. Meteoroids, the shapeshifters.
I call them shapeshifters because the name of this object actually changes entirely depending on its location. It's like a 3-step journey. Step 1. Out in space, floating freely, it's a meteoroid. These guys range in size from a microscopic 10 micrometers up to about 1 meter. Step 2. If Earth's gravity happens to pull it in, it enters our atmosphere. The molecular friction between the air and the rock generates intense heat, causing it to literally burn and streak across the sky as a glowing meteor. Most of them, thankfully, burn up completely right here. But, step 3, if the rock is large enough to survive that atmospheric inferno and physically strikes the ground, it earns its final, heaviest title, a meteorite.
So, the crucial point here is understanding the sheer, terrifying velocity involved in this process: 42 kilometers per second. That is the top speed of the fastest meteoroids hitting our atmosphere. Just count. 1 second. In that single tick of the clock, the object has traveled 42 kilometers. It's mind-blowing. And when a large cluster of these high-speed meteoroids enters Earth's atmosphere all at once, the sky lights up with multiple burning streaks, creating what we beautifully refer to as a meteor shower.
Section 5. When space rocks strike.
Remember earlier when we saw the main asteroid belt safely tucked between Mars and Jupiter? Well, notice the rogue orbits located outside that main belt, specifically the Apollo, Amor, and Aten orbits. These paths are incredibly dangerous because they actually intersect or come frighteningly close to Earth's orbit. If Earth and an asteroid happen to arrive at that intersection point at the exact same time, well, the result is a catastrophic high-speed collision. And it's not just asteroids. Strong gravitational pulls from outer planets can even cause comets to slip out of their orbits, posing a very similar threat to us. To visually emphasize the stakes of an intersection like that, just look at these two incredible images side by side. On the left, this is a visual representation of what paleontologists believe wiped out the dinosaurs, an asteroid roughly 10 kilometers in size colliding with Earth. A rock that size, it literally results in the mass destruction of living things. On the right, we see the very real aftermath of a much, much smaller strike. This is a massive crater in Arizona, in the United States. It's approximately 1.2 kilometers in diameter, completely carved out of the Earth by a meteorite impact roughly 50,000 years ago. When these shapeshifters actually strike, they leave a permanent scar on our planet.
Section 6. Defending Planet Earth.
So, monitoring our skies is absolutely a global effort, and it requires dedicated institutions like the Malaysian National Space Agency, also known as ANGKASA. Their job is driving and monitoring the development of space science in Malaysia. Agencies like ANGKASA are totally essential because by tracking these celestial bodies, mapping the asteroid belts, monitoring those scary Aten, Amor, and Apollo orbits, and predicting comet trajectories, we take the absolute crucial first steps in planetary defense. We have to know what's out there and exactly where it's heading to protect our future. And that brings us to the ultimate question, one I really want to leave you with today. If an agency spots a massive space rock on a direct collision course with Earth, what happens next? What monumental physics and engineering problems do scientists face when trying to actually destroy or deflect an asteroid flying at 25 kilometers per second? Just think about the sheer mass, the incredible velocity, and the unforgiving vacuum of space. How would you save the world? Thanks for joining me on this incredible journey from deep space down to Earth's surface. Keep looking up and keep questioning what's out there.